do this sort of like accumulation argument for convolution before. So I think that's a pretty novel result in of itself that we might like post a blog post or maybe write up a paper or something on it, which would be pretty sick. But yeah, what I've been doing lately is just like expanding the functionality. Basically, we now have like most of the functionality that we had before with the polynomial constraints now with accumulated arguments. It's just a case of like, I don't know, like adding a few operations. Like I just added like addition between two vectors or multiplication between two vectors or subtraction between two vectors. So that's all done. And yeah, so pretty soon we're going to be swapping out the old polynomial arguments with these new accumulated ones. And hopefully you'll be able to try that out by the end of the week or early next week. But yeah, that's basically it. But yeah, everything's going real fast, basically, is the summary.
No. I'm just wondering how we went on any surprises.
Is it
Any questions?
7 or 17x?
Oh, 7D, 70 for some of these things.
Wow.
Yeah, it's pretty
Okay.
crazy. Like some of these things that were taking like 100 something seconds are now 1 point something. So it's pretty quick.
Wow. So
Yeah.
like proof generation is a few seconds now instead of minutes.
Yeah, exactly. It'll be pretty short, I hope. And combined with the lookup improvements we had, hopefully you'll get like significant improvements by next week, which will be pretty sick.
What were the
This is
lookup
going to-
improvements?
Or
Oh, I was just asking, what are the lookup improvements again?
This was from 2 weeks ago, where we delayed, like, basically we put all of the lookup tables into a single, yeah, all of the lookup arguments into a single lookup argument, basically. That was kind of the gist of it. We introduced a flag to be able to use that. I don't know if you guys have poked around with that. But yeah.
Okay. Super dope. Great stuff, Dante.
Yeah, that is it on my end.
Cool. So with the accumulation, anybody want to talk about the account abstraction integration?
yeah, Richie, you want to share the improvements and the findings? I guess Richie is he's just as a listener. So I can share a little bit. The Hunters in Hunter team have been moving forward with account abstraction integration, and what we found out is that some of the parts that we are touching right now, especially the previous the signature verification guess, it's still work in progress from the ERC 4327 team. And I messaged Dror about it. He said like, oh, this is not finished. That's why sometimes it goes through and sometimes it fails, basically. Like if you send the same transaction 3 times, like 2 times fail, 1 time not. And when it fails, it's giving error calculation on gas fee for the verification part. Basically, how account abstraction works is there's the verification function, which will allow you to use that account as a means to send transaction or not. And what we did is we are adding the EZKL verifier contract on this verification contract, on verification function. So, and basically we are sending the proof. If the proof is valid, you can send the rest of the transaction, which in our case is basically getting the rewards for the correct image. So yeah, so this part is, I think it means that our code works basically when this gas calculation part is more solid and it's working properly, this implementation should work. One of the things that we will do with account abstraction also is to start integrating. I was talking to Jason this weekend, and we will try to add a command line endpoint of generate account abstraction with this model. So we will just to make it, you have the Onyx file, you input it, the same way that you can generate the verifier contract, you will be able to generate the account abstraction wallet that have the gating using that specific machine learning model. So that's one thing that we will start testing out, and hopefully there will be some issues around. Please don't take them that day. I think there will be very good first good issues for especially because it will not touch anything below the most basic layers of EZKL. It will be just like an add-on on top, which will just be generating the contract itself. So yeah, hopefully we can start this simple implementation this week. We'll probably start a little bit slower as we're not as fast in Rust and in the EZKL repo, but hopefully we can start something this week and also start creating some issues to be sharing with the community also. So that is for the account abstraction update. And yeah, any questions?
Danilo, just out of curiosity, that process, can you listen me well?
I
Yeah.
can hear you.
Okay. That's the process for account abstraction that you mentioned is like generating a verification with hard hat for ETSM, something like that.
So
from
the one that we used for Hunters x Hunter is basically we implemented that image recognition to allow you to trigger or not the transaction using that wallet. So in our cases, if you find the correct image and you generate the proof that you found the correct image with EZKL, then the transaction, you can send the transaction with that specific wallet, which in the case would be to get the reward for yourself. But there are different models, there are different machine learning models. We also want to test with bigger models. So we are creating a template that I think someone is, a template where you will output an account abstraction contract code with the verification already implemented for as a layer for that the zkml verification layer on the account abstraction verification function already implemented. So that's the idea for it.
I see. Thank you.
I did ask, I was curious about call data with account abstraction, and if that's relatively straightforward, like similar to what you would do if you're just doing a regular call data.
It is, there is some, like, you need to treat it a little bit different. On the opcode level, I believe it's the same, but first you have to send a transaction to the account abstraction contract, which then will do another call to another contract. And I think what the bundler does is basically he prepays the gas for you, and then he requests the payment from the account abstraction wallet. Like there is this step around. But I think the opcode level, the call data should be similar. Like there is no change on the type of opcodes that are used for the account abstraction.
Okay, got it. That makes sense. Cool. Did anybody else have any questions? If not, we can move on to the Face ID model. So along with Hunter Z Hunter, we're working with, we actually have a hackathon team for scaling Ethereum with Paul, Brent, and I, and a few others, and a couple others. So we were working with the MobileNet V2 neural net to recognize faces. And, you know, of course, with on-chain Face ID, you want to be as accurate as possible. So we want accuracy over efficiency. But one thing that we noticed is that when we tried to take a small portion of the model, like we did with the first version of Hunter Z Hunter, it didn't really work out with facial recognition. So what I've been working on is taking the full MobileNet V2 model and putting it on EZKL. Have been having some difficulty generating the Onyx file from it, but should have that done relatively soon. And then another suggestion from Danilo, the other Danilo, was to use a neural net called the Deep Pyramid Single Shot Face Detector. And I was looking at the paper. I could actually send the link in the call, but I was looking at the paper, and I think it would be good if we had multiple people in the images, because that's what it's kind of designed for. But since we're going to be using just a regular photo, probably like a photo library in JavaScript that could take a photo from somebody's front-facing camera, I don't think we'll have to worry about that. And then also random forests were brought up, but that is that's probably not the best solution moving forward. So I just shared the link to the paper in the Telegram on the Deep Pyramid neural net, but that's the updates that we have on that so far. I'm also working on the verifier, so I'm going to be testing out the WASM verifier with this model as well. Cool. And if there aren't any questions, then you can just open it up to anybody who has questions. I personally wanted to ask Dante more about the accumulation method. And if we're talking about Sunday X, do you think that we'd be able to put bigger models there? And if so, how much bigger?
Okay, so something to realize right now is that, so basically, okay, a good way to think about this is that even though we are going to be faster, we might be able to run some of the models that we currently have in a faster fashion. We're still going to be constrained by currently in the way it's set up, we're still going to be constrained by the log rows, like the maximum log rows of the circuit. I'm going to be trying to design some methods where, like, for example, if we max out one row, it'll spill out into another, so we can start to fit in bigger models. But something else to realize is that, like, turning convolution, for example, into matrix multiplication eats up a lot of column space as well, because instead of like having one small conv kernel that's assigned within the circuit, you now have this giant equivalent matrix that needs to be assigned within the circuit, so you're kind of eating up more circuit space. But
Does the matrix
yeah,
take
it's like the size of the output, basically.
And
because you have to multiply into
a cell in the Halo 2 table?
And yeah, in the larger circuit layout. The way to, yeah. So I'm going to be playing around with methods to like get operations to spill over into other columns. But that'll probably happen after That's the integration. Like I just want to make sure that it works once integrated, but then once we get some of this like spillover type stuff, hopefully we'll be able to fit in larger models.
Mhm. Super cool.
Does that make sense?
Yeah.
Yeah, I definitely need to talk to you to get a better view, or at least a more in-depth view, but on a high level, yeah.
All right. I had another question with regards to the log rows. So I believe this is designed for a single machine. Are there any like plans to kind of distribute like this computation, and if whether is like distributing the log rows into a different machine possible? So I'm like thinking of the setup, for example, instead of having one massive machine with a lot of RAM, we could have possibly maybe about 3 or 4 spot instances with AWS and kind of shut it across like small cheaper compute instance versus like one massive computer. So I think this might be also like a bottleneck for quite a lot of applications on EZKL because like not everyone has a supercomputer at their disposal.
Oh yeah, 100%. Well, hopefully like the changes that are coming out reduce the computational burden for proving. That's the first thing. And then B, well, the first thing is that we want to get like the proofs to be as efficient as possible, irrespective of how they're sharded. So that's like step one. And then in terms of sharding, I guess there's multiple methods. Like in some sense, like recursion would fit into this to some extent, like the ability to feed one proof of like, I don't know, like a sub network into the proof and into like the proof for the remaining network. If that makes sense, like say you have a giant network and you split it in two and then you do the proof for the first half and then feed the proof of the first half into the generation of the proof of the second. Those sorts of things like that can already help to reduce computational burden as well. In terms of parallelizing it, yeah, for sure. There's some algorithms for proving. Jason, I can't remember which one. There was one for like one of there was a GPU prover that was released recently. For what was it for?
There's a few different GPU and FPGA provers that are out there. I'm not sure that any of them plug into Halo 2 right now. And sometimes that's a separate kind of, I mean, we can fork Halo 2 and do that. It's hard to do it as a client of Halo 2, like downstream of Halo 2. So I think if we fork it and do it, or if we get a change merged, or to upstream that supports more GPU or distributed provers. And I mean, of course, you have to think a little bit about what parts does it make sense to distribute. Like you should commit commitments for your transforms. Everything has different properties. I could expect that the communication costs are going to be significant for parallelization, and a similar problem is cache efficiency. And I feel like the cache efficiency might be lower hanging fruit than parallelization.
Yeah, for sure. I was gonna say if we start distributing stuff, we're gonna have to build like a networking stack on top of that, which would be like a significant undertaking at the moment. We're definitely open to, but yeah, it's pretty complex to start to distribute these sorts of workloads.
Yes, agreed. I guess it could be like the case stuff is probably a lower hanging fruit right now. Yeah, I guess I can also give some updates on my end. So I'll be writing like Python bindings for EZKL on PyEZKL. So this way, it's gonna be possible to kind of like use EZKL with like Jupyter notebooks. So I think like right now an issue with it's just like kind of like a workflow thing. Like most of like the data science stuff you can do in Python, but not so easily on Rust. So it'll be nice if you can just have like Python binding. So I have actually wrote an issue for this in PyEZKL, and I'll get like Python bindings on PyEZKL and hopefully commit it to like the main branch as I kind of like work along all the various features of EZKL. So yeah, that's one like project that I'm working on right now. So hopefully it's much easier to use, like Jupyter notebooks, because I had like this problem, like you want to do like data science experiments, and you have like a Rust environment and a Python environment, and it was like kind of like not nice. So it'd be nice to just like have like the bindings of PyZQL. So like give me some time, I'll work on this.
I think that's amazing. Yeah, well, one thing we did for Hunters x Hunter is we created a Rust server for EZKL, which technically could be then just be fetched by any language, JavaScript, Python. I don't know if that interests or could also help from what you're doing. I like separate from the Python binding. I think the Python binding is amazing and it should be there like separately. But maybe we could see if we can have like a simple sample Rust server template also somewhere so that people can just come and deploy their simple server for EZKL proving and verification. Of course, we don't want this to be like we don't want the proving to be on the server sides, but I think for now and for like in this testing phase and getting people to try it out, especially for users who or developers who are not familiar with Rust and want to try it out on JavaScript and other languages, it could be a way for them to try that. They just need to run the server and then have an endpoint and interact with it. Yeah, maybe.
It can also be just used locally, right? Like an RPC server or
Yes.
daemon or whatever.
Yes.
Like it's just another way to wrap something, which some people might find cleaner
Yes.
for certain types of applications.
Yes.
Yeah. I did have one question, but I see Brent has had his hand up for a while. What's up, Brent?
Oh, okay. I unmuted myself. Sorry. Can you hear me?
Yep.
Okay. So this is sort of a tangent. I guess I was wondering about. Well, I know asking more about. I'll have to ask you outside how to build the outcome abstraction while it's like trampoline and get that in. But the other, I think that might be out of scope. But the other thing I've been kind of wondering on the side is I've been asking about recurrent neural networks, or I guess Taban said something about what was it? Yeah, I'm drawing a blank. Hang on. Oh, transformer model. So that's Hugging Face stuff. So I was still trying to see if Ezekiel would take something with it looks like a variable length input, but I guess the only thing I can figure out is that vocabulary size would be fixed. So if you use like the ASCII vocabulary, you get up to 128, but you can always train it with various sizes of text, so it's not going to be like in Hunters x Hunter like a 28 by 28 by 1. So still trying to figure that out for Ezekiel. So I don't know if anybody has any ideas. Open up a discussion on the GitHub.
Well, I guess a really simple way to deal, if you wanted like a really simple version, is you just determine a maximum maximum sequence length, and then just assign zeros to the things that are unassigned for any given data point or something. I mean, that's the really simple way to start, right? You literally just zero out the, and isn't that how they do it with transformers at the moment? Like my impression was that like the inputs to transformers aren't necessarily like the inputs in particular, but I could be completely wrong.
So is a sequence length like it's not the vocabulary length, is it the kind of the recurrent, how many cycles you have?
Yeah, yeah, exactly.
Okay.
Because you could start with a fixed number and then just have a null. A null, basically, some value is equivalent to a null token, like which means, and then as you train your model, it should learn to ignore it, basically. When set to that specific value, like that would be the idea, I think.
Okay.
Wait, I'm gonna quickly Google this. Yeah, I think in some of the masking that happens with, like in the way like transformer architectures are defined, they explicitly define like a null token or something as their, but it might just be for intermediate representations, but something to check.
Okay, yeah, that's some progress for me. So, hadn't thought about that.
Cool.
Yeah, to be honest, new to everything here. So.
Fair enough.
Yeah, Dante, I have a question. If the proving time gets 7 times faster, yeah, I guess that's the same question as Sean in the same of, because I guess the gap right now, or the bottleneck right now for generating some proofs, or its time and also the amount of RAM. So I think it's basically how, like right now I would say, like for a normal computer the limit is 2, like on using aggregation, or I guess even without aggregation the limit is a few layers. Do you think this will improve to like dozens of layers possibility, or maybe even
Yeah,
hundreds of?
I think we'll get improvements in terms of depth for sure. Like in terms of depth, we should definitely see an improvement for proving time. 100%. But the only caveat I was adding earlier was in terms of width. Like there is yeah, it might be that we max it because I won't be rolling out like the spilling over into next column sort of thing. There's the potential that you max out the maximum number of rows much more quickly just because of the way the arguments are constructed relative to how it was before. So that's just something to note, is that you might get more depth, but width, I'm a little, not sure entirely.
I see. Yeah. Either way, I think it's exciting, and I also like, this is like just randomly I'm seeing this post around, and how Mac have been creating this GPU like more efficient kind of RAM. Even the new MacBooks, like they don't call it RAM anymore. And I think there's also some code around it. And I think there's some ZK zero knowledge proof projects that also implement this for GPU acceleration, which is called, I think, Metal. So I'm wondering, like, would that be relevant for EZKL too? Yeah.
Yeah, I mean, definitely, it would be awesome. Like already, my MacBook is pretty quick to do some of these things, like relative to older architectures, just because the like memory swap is so fast. But yeah, I mean, I guess it's kind of gonna depend on, like, at some point we're gonna have to prioritize for a specific architecture, and it's kind of gonna be determined by what most people are using. Like if switching this over to like M1 accelerated or M architecture accelerated stuff is, I mean, yeah, definitely cool. But I don't know how many people or how useful that is for applications. Like it's definitely useful for iterating and prototyping for sure, because so many people use MacBooks when they're developing locally. But, yeah.
Makes sense. I think Solius raised his hand.
Yeah.
Hey guys, do you hear me?
Yep.
Yeah.
Yeah, so pleasure to be at this meetup and this really nice project. This is EZKL, and I have a question on the other types of machine learning, such as decision tree. I see that you have that you have issue open the project at the GitHub, and I'm just thinking, you know, like maybe there is some source where I can read like what are the efforts needed to add this like decision trees or some other, even other ML methods to the framework.
Okay, so yeah, good question. So a lot of those models have representations. So the way the library works is that broadly it maps an Onyx node. So it's like some sort of operation defined as an Onyx node, and then it maps that to a circuit equivalent, basically a bunch of constraints into a circuit. What's tricky about the decision trees and random forests and those sorts of things is that they do have Onyx representations, like through, I think sklearn, you can export stuff to Onyx, but they're represented as a single node. So you have to map an entire decision tree. It takes in a lot of parameters, basically, and you have to map that single node to a whole decision tree. So it's kind of complicated in terms of like parsing all of the different Onyx inputs, but that's not impossible. And then you have to basically map a decision tree into a bunch of constraints, like circuit constraints. So it's twofold. Some of it is like processing like Onyx files, and then the second part is mapping all of that into a bunch of circuit constraints. Does that make
Yeah,
sense?
but is it? I think on a high level, it of course makes sense, as this just looks like you know, converting something to something else. Yeah,
Yeah.
it makes sense. However, like I mean, I'm just trying to get intuition here. Is it? I mean, do you see that it's going to be pretty optimal in terms of you know, like the circuit size, or is it more like you know, trying just to make some compatibility or some conversion just for sake of conversity, and not something that the end result is going to be optimal enough for real world usage. Do you have some, you know, some insight here to share?
Yeah, I mean, I could see decision trees, especially for high dimensional spaces, if they're just like represented as a bunch of polynomial constraints. I could see that exploding in terms of like proving time, which could be bad. But we had this idea, which was so basically with a decision tree or a random forest, you're just mapping a bunch of inputs to an output. And we were wondering if like a really simple path to doing that, and this gets a little bit tricky with if your inputs are very high dimensional, and it would require a little bit of innovation in terms of like being able to do this. But the idea would be to represent the whole decision tree or random forest as just a lookup table. So basically, you represent it as a lookup argument from inputs to outputs. You generate predictions over the whole space of possible inputs, and you use that to populate your lookup table. And then instead of like having to convert like all of these decision trees and all this other stuff to like a bunch of polynomial constraints, it's just one single lookup argument. So you replace the decision tree with a lookup table in the circuit. Maybe that'll scale. I don't know, but it would be cool to explore for sure.
Okay, so just like the current state, it's a pretty early stage, right?
Oh yeah,
I mean,
I
I
think
we
sort of
haven't thought of the best, and I think of it as we haven't yet thought of the best. Maybe you will think of the best way to represent a decision tree as a proof in the Halo 2 system, and in a way that's hopefully compatible with the rest of how EZKL works. there's sort of an internal EZKL API that lets us compose nodes. It'd be nice if it would plug into that. There are a couple of ZK decision tree projects out there, like in CirCom and stuff. And so it might be that those methods will translate well. They might not too. So I think it's just, yeah, early on the thinking of the right way to do it. It's probably not that, there's probably a good idea that will represent it, but I'm not sure anyone's come up with it yet.
Okay. And apart from decision trees, is there any research of any other ML methods, like whatever, like supported vectors or something else?
Yeah, I mean, a lot of, so that it is kind of tricky for some of these models because they involve, like they might involve probability distributions or sampling something from a probability distribution, which can be difficult to emulate in a circuit. Some of these things, like if you have kernel-based methods, you know, you're just multiplying things. We can definitely represent that, like something like a support vector machine. There's nothing saying we can't represent that in terms of like circuit constraints. So it probably could be built with some of the arguments that we have now. It's just a question of implementing it. And again, like with the Onyx framework, because basically Onyx is like very good at representing lots of composed individual operations. Like it was really geared towards like graph-like computations that might be, you know, that might come from neural networks or anything you spit out with PyTorch. So some of these other models, which are mainly implemented in like sklearn, are kind of awkward in the Onyx format. I think support vector machines are also going to have like that single node representation. So we just haven't really prioritized that, if that makes sense.
Okay, and the progress is probably like, where could we follow? Is it on the issues section in the GitHub, or there is somewhere else to?
Like for specifically for decision trees.
Essentially for the other ML methods like decision trees or support vector machines or whatever else that you are planning.
Yeah, I mean, realistically, that's not going to be a priority in the next few weeks. So if you were interested in like doing that, I'd be very down to hop on a call with you and just run you through a few ideas on how to do it. If you have a pressing need for decision trees inside EZKL, very down to get you up to speed if you want.
Yeah, actually, I'm more interested into to see how it evolves, and if I see some project with that supports like a more machine learning methods, and I can track the progress there, it just gives a good overview of what is possible to do within this new area. So yeah, not particularly stressing something, but just trying to follow what is going on and what is possible to do.
Gotcha. I mean, yeah, so there's a bunch of examples inside the repo. There's a bunch of issues that are going up, and we're tracking progress against those. But there's a bunch of examples in the repo that basically demonstrate like the workflow of how you go from implementing something in PyTorch, dumping it out into Onyx, and then running proofs on top of that. I mean, some of the work that JSeam is doing to basically create bindings from the main EZKL library to Python might mean that you never need to interact with Rust. You can just do it all from a Jupyter notebook. So you like train some PyTorch model and then don't even have to go through some of the intermediate processes that we currently have. So it would just be like a regular data science flow where you train some model in PyTorch and then you can just run proofs on top of it from your Jupyter notebook or something.
Yeah, this sounds.
Does that answer your question?
I think
Yeah.
yeah, more or less. I think I should just follow your examples subdirectory and
Yeah, cool.
see what what new you have there. Yeah, that's this
Yeah.
makes sense. And one more little question. So, did you try to explore some other alternatives like Noah language? You know, like for something which is a bit easier to prototype or slightly faster to move forward. You know, I mean,
Well,
in Rust, it's not that easy to do things quickly, and
yeah.
sometimes you
Well, let me
may,
answer that
yeah,
in two parts. Like stuff like Noir and Circom is super cool. Like it's really great to have, the ZK specific languages. The problem is that those languages are kind of poor in terms of like external package functionality, which we definitely need. Like we need to be able to interface with like Onyx, all this other stuff. If we want other people to build servers and runners and workers or have WASM compatibility on top, like Rust is going to blow all of these other things out of the water. So like just having those sorts of capabilities that you get with like a more general language is definitely super powerful. I would say that, and yeah, and to that point, like Halo 2 is written in Rust. It's one of the better production ready ZK proving systems out there. So it's also kind of good to build on top of that. And it means that because you also have this general language, you can create abstractions on top much more easily than like, I'm less familiar with Noir, but like say for example, Circom or something. I know Noir is actually, I'm not going to say anything stupid, but but yeah, that's kind of the gist of it, is that because we want this to connect to lots of other things, we need to have the capabilities of like a fully fledged language, basically. Does that make sense?
yeah. You know, the reason why I'm asking that is because you know there is pretty big gap between the people that I mean majority of the people that are good at machine learning and the majority of the people that are good at proving systems and Rust. You know. So,
Yeah, for
so we're
sure.
just thinking how to bridge this gap, you know, and like
Yeah,
Noah was seems like a good option, but it's very early. We played a bit with it. It's very early, limited with you know, limited in terms of what you can do, and at least seems now there is no way to easily join that with more system level programming that you most likely need, you know, because this proving system that proving environment that Noah offers you is a pretty isolated, you know, it's pretty limited. So, and this is not
yeah, for sure.
not capable of what you are doing with the framework, you know, which needs to do all kind of stuff. So yeah. So yeah, that your
Yeah,
answer
for sure.
definitely makes sense. Yeah.
But also like to help bridge that gap between like machine learning practitioners and maybe data scientists and like proving like that's part of the idea with the Python bindings, is that you can work, hopefully you never have to interact with Cargo or Rust or anything. And then basically you can do everything from your usual like data science sandbox, like straight from Python.
Yeah, makes sense. Makes sense. Okay, thanks.
No worries. All right, I gotta hop off, guys, but
That was an awesome
Yeah.
discussion
yeah,
right
thanks.
there.
Yes,
Thanks everyone for coming.
we can wrap up
Yeah, for
the.
sure. In terms of where to
Thank you.
post the recording, Jason, is there like a Gmail that we can use for YouTube?
Sorry. Oh, for YouTube, you said?
Or just anywhere.
to post
Like it could be Dropbox.
Yeah, sure. I mean, if you want to connect with me
I think
on
YouTube
Telegram and
is nice. Yeah.
Okay.
I think YouTube is nice because you can just then share the link and people can just come and watch it. Doesn't have to